All right, ready to rock. I don't have a stash of books. Let me just say that up front. So I'm going to have to win your attention somehow. Allow me to start with a scenario. So imagine that you and like two of your colleagues, maybe two people you meet here tonight, you want to get together and you want to form a new startup. So in my case, I actually chose Joel and Eduardo because they're kind of good at what they do. So you're trying to think, what's on trend? I want like the hottest and best thing on the Internet of Things, and I'm going to get so much funding for it, and it's going to be amazing. So as good developers, the first thing you do is you step into dev mode. So you're sitting there, you're just trying to code something out, you're trying to get some form of prototype up and running. And after some extensive user testing, which basically involves asking your friends about what you think is cool, maybe some Twitter magic, you decide on OMG Amazeballs, a beautifully simple HTML5 front-end experience designed to make social media more social. I mean, wow, right? I have no idea what any of that means, but apparently this idea was so crazy, or as the kids would say, totes amazeballs. A venture capital firm immediately provides you with like $60 million of pre-product, pre-revenue funding for 50% ownership of your company, providing that you can get 10,000 users in the first 3 months, and then 500,000 users in the next 6 months. Because that sounds right. That sounds like it's possible, right? Totally legit. So, needless to say, this is the reaction you would expect. Yes, I'm super excited. You and your team are so excited. So you sit there squirreling away, you do some viral marketing, maybe set up some fake accounts, try to get some attention, and before you know it, you hit 10,000 users, which, as we all know, means make it rain. We get our first set of funding. It's going to be amazing, our first payday. Although that being said, I think there's probably an argument to be had with the profit-sharing arrangements. I think I have about $4. Eduardo probably has just north of 10, and Joel at the front, well, come on, I think it speaks for itself. So just as you're closing in on 25,000 users, of course, because that's just easy to do, you notice your user count gets a bit flappy. So it starts going up, starts going down. You can start to get traffic spike and then drop, but your servers are running hot. You don't understand what's going on. There's a lot of traffic going through your servers, but your user count is increasing. So before you can look any further, or before you try to dig into it, unfortunately, because you're the new hotness, this happens. Someone forwards you this article. Newly discovered weakness in OMG Amazeballs reveals user info, causes mass sadness. So it turns out that some nefarious security researcher found and exploited a cross-site scripting vulnerability in OMG Amazeballs. So this was a stored XSS, as Parisa mentioned earlier, or cross-site scripting. I'll refer to it as XSS throughout the talk, which allowed them to insert arbitrary JavaScript into all pages that were shown to the user. So this JavaScript could send copies of all updates made to OMG Amazeballs, including your user data, in-app usernames, passwords, anything that the user could do, this JavaScript could perform on behalf of the user. Oh. Naturally, sadness sets in, but you get to work trying to figure out how this happened. I mean, the money is gone, but as professionals, you're interested in wondering, how did this happen, and what can I do next time differently to make sure I'm not vulnerable to this class of bug?
And revenge.
Revenge, maybe. But unfortunately, you look around the site to no avail. So you don't know what's happened. You don't know how the person's exploited the bug. So you're looking around, you're looking in logs. It doesn't really make sense. Then you go to one of the pages of your top users. You go, okay, so who's had the most traffic? And then you see this. Real name. Oh, man, really? So again, you were confident that you were sanitizing data on input and escaping that data on output. But somehow, someone's injected control tags into the page, and just as Parisa highlighted earlier, they're able to load a script. But in this case, they're not popping an alert box. Looks like they're loading something from the user profile directory, so /photos/legit.jpg. You go and look at legit.jpg, it doesn't open. You're like, oh, that's interesting. So you download it, and you download it to your Linux box, and you run file on it, and you notice, oh, this says it's of type text. Oh, that's really strange. And you have a closer look, you open in a text editor, and it's full of nasty JavaScript. So we're owned. It's done. So this little piece of code that runs from the script directory, every time this page was loaded, basically could do anything on behalf of the user and was forwarding that information. Needless to say, none of you want to end up here, but I'm sure you've been here. So believe it or not, cross-site scripting is the most common bug on the internet, the most common security bug on the internet. So I'm here to talk to you tonight about some of the most common bugs that we see are reported by external security researchers under the Google Vulnerability Reward Program, and to test out some of your elite hacker skills with some examples later on. And although I lied and I said I didn't have books, I've got Chromecasts, so brace yourself. Before we can get there, we need to have an understanding of how these types of bugs work. So how does it work at Google? So this slide basically covers the range of payments that we make for a single bug of that type to security researchers. So in a non-integrated acquisition, so that's basically a company that Google has purchased, but Google hasn't moved their product onto Google systems yet. So it's some software stack that we've purchased and come along for the ride. That'll score you $100. But all the way up to on accounts.google.com, a typical XSS will score you $7,500. And if you can get remote code execution anywhere on Google, you're looking at about a 20 grand payday. Note that over the period, and you might be wondering, yeah, well, how often does this happen? I mean, really, how much do you pay out? We have paid out over 1.6 million in cash for the web program alone. Other programs at Google, including the Chromium Rewards program, which rewards bugs found in Chrome, and also the Patch Rewards program, which provides money to people who submit patches to popular open source projects that patch security bugs. We've paid out over $3 million to date. As you can see, it's a bit of hard work. We receive over 20,000 reports, and we've only filed about 3,500 bugs based on those reports. So how does it really look? These are the numbers for externally reported bugs in 2013 to Google. As you can see, XSS and XSRF, or CSRF, dominate the field. So these are the bugs I'd like to focus on tonight. We do have other categories, so mixed content, for instance, is when you might have like a page loading over TLS or HTTPS, but you include something over HTTP. So you might be sourcing a script over HTTP. That actually violates the integrity of the page. And in Chrome, you'll actually get a nice little, sometimes you might have seen the padlock with the little yellow triangle on it. That will warn you that there's mixed content running on the page. The other category includes other bugs that Parisa was talking about, like SQL injection, remote code execution, auth bypass. All of those kind of lump into one category because when they're on the slide, you can't really see them. There's also another other category which isn't shown, just for transparency. That includes types of bugs which don't neatly fall into one specific category, like it might be a hybrid type of attack which uses several different types of bugs. And finally, on the side here, info leak. I kind of grade that out, but I think it's important to give that some context. So at Google, we're very conservative when we file these types of bugs. So an example of a bug we might file might say, you can tell that a web server is running the latest version of Apache. Well, you can tell that this web server is running Apache v2.4.9. In and of itself, that might be interesting information for the developer, but if it's the latest version, there are no publicly known exploits. There's not really there's an argument as to whether we should be filing those type of bugs. So that kind of explains why that number is so high, not that we're leaking all over the place. So Parisa spoke about cross-site scripting, or XSS. So what's this kind of less popular sibling, XSRF, and how does it work? Well, that stands for cross-site request forgery, sometimes referred to as CSRF. Eduardo, who's speaking next, is an information security purist, and he finds it very offensive that I use X in XSRF. So I need to point that out to you so you don't mention it in his talk. He'll get very upset. C is for CSRF, X is for XSS. So please take that home with you. What does it do? So it's a class of attacks against applications in which state-changing requests are predictable to attackers. What does that actually mean? It means it allows an attacker to silently perform an action on behalf of the user without their knowledge by piggybacking on top of a session that they already have. So it basically attacks and targets users in authenticated applications. So for Google, that's a problem for us because our users are mostly signed in all of the time. So if we're signed in all of the time, and we expect our users to be signed in all of the time, then this type of attack is very important to us to make sure that we can mitigate against it. So how does it work? The very high level, let's say you were using some blog platform, of course, Chromium, or Chrome, I should say, and you send a request to delete my blog. I'm logged in, please delete my blog. Response, jolly good, blog deleted. Winning. We must be on google.co.uk for this one to actually work. So what's actually happening in the background? Well, your browser sends the request, it has the blog ID in it, it has the site, and it's also sending your cookies across with it as well. So what the browser is doing is every time you make a request to that site, if you have cookies, it will helpfully provide the cookies along with the request. So here, we ask to delete it, and our response is OK. So what happens when someone evil tries to do this? So they're like, yeah, can you delete my blog? Totally my blog. Seriously, it's my blog. The response you'll get is not you, no cookies, no dice, or simply 403 forbidden. The reason this happens is because you don't have those cookies. So if I'm an attacker and I'm trying to impersonate your account, I don't have your cookies, so the browser does not send the cookie along, and therefore I get the response that, no, that doesn't work. So taking that into consideration, how do we actually do an XSRF? Like, how does it actually work, and how do we attack logged-in users to perform a function that silently happens in the background? Well, the first thing we need to do is set up the XSRF. So I'll show you a code snippet later of an example of one. But in this case, you can either set up your own kind of dodgy site and try to get people to come to it, which is a bit more difficult. But what you could do is find a site that allows you to inject HTML into it, or find a site which, if you use some of the tricks Parisa was referring to earlier, you can actually get it to accept HTML that renders in the page as the context of that page. Now, there are well-known cases of people doing this, especially on forum sites or in comment fields. So imagine if you could inject this type of HTML into the comment field of a news site, and then everyone who visited that news site or saw that page is possibly vulnerable to attack. So let's say you set this up, you set up the payload, and you let it run. Let's use the example of the news site. So then what happens is the person requests the site, like they type it in, they hit enter, you get the request for the site, and you get the HTML returned to you. And in this particular set, you have some images to load. So there are some image tags all the way down the page, and it loads it. But one of those image tags is a little bit dodgy. One of those image tags actually says, oh, hey, server over here that's logged in, can you load this image for me? I really need it for this page. And what's actually in that request is I'm asking that logged in server up here to delete the blog. And the request I get back is, OK, blog deleted. So this works because I've enticed someone to visit this site. When the image loads, it's actually not an image at all, and it's sending a request to a server that I'm already authenticated to. And my browser, being the good piece of technology that it is, will send my cookies along with that request automatically because I'm already logged in. So what I'm actually doing is getting this person to initiate a request on my behalf silently in the background. Now that might sound a little hardcore, but that's all it is. So here's my cool site. If you weren't sure, the H1 tag says cool site. I have an amazing GIF, or GIF. We can have that argument over a drink. And then here. Oh, I want to load another image. It's just at here /delete blog. And here's my blog ID. And my style tag says display none. So it's not going to mess up the formatting. It's not going to give me a broken image link. It's going to happen completely seamlessly in the background. And my browser, being the good piece of technology that it is going to load this. This will happen secretly in the background, and then we get thanks for visiting. So that is how an XSRF works. So you might be thinking, how do I defend against this type of attack? Like, how can you stop this from happening? If the browser's going to send the cookies, then do I have any chance? Like, how is the server going to know that it's me sending it, like I'm interacting with the page, versus someone taking advantage of this piece of technology in order to exploit it? Well, the solution is you use what's called tokens, or an XSRF token. Now, a token is just a secret, unguessable, random string which is provided by the server and generated by the server and provided to the client. So you would use this on a state-changing submission or something that's very sensitive. So if you were asking someone to perform a transaction or do a post on a blog, or you are asking someone to change their password, for instance, what you can do is use a token. The server will generate the token, provide it to the client, and go, here's this random string, and when you want to go ahead with this, you reply with the request and you also send the token along with it. So that way the server knows that, yes, I received it and I'm sending it back. So you might be like, well, that might be hard to implement. How do I do that? Well, it's highly likely your favorite framework already has them. Highly likely. And you should listen to Eduardo if you're unfamiliar with this speaking next. He'll talk a lot about frameworks. For those of you who are familiar, and I expect there are some of you in the audience who are very familiar with CSRF-type bugs, please remember to test your fail conditions. So it's very easy to set it up and have it running, and it'd be, you have it running and you've checked it, and it's brilliant. And then you make some seemingly unrelated changes somewhere else along the website, and suddenly the token is not being verified anymore. Or you can replay older tokens from a long time ago. So it's very important that if you are using this, you test your fail conditions. All right. So now that we've covered XSS and XSRF, it's time to see your amazing computer hacking skills in a couple of games of Spot the Bug. So I'm going to give you two examples. These are real bugs that were reported under the Google Vulnerability Reward Program, which received cash payouts. The first one, I would hope most people can spot it. And again, if you really want a Chromecast, then you probably have to be very quick on this one. The second one is not so easy, and I just kind of want to highlight the complexity of some of the bugs that we see. So, who can see a bug in this code? Set is free true. Surely that's not going to work. It works. So this is a bug from 2012, where what actually happened was, this was part of some testing, and this was always validated on the server side. But we made a seemingly unrelated change, and what actually happened was any changes on the client side weren't picked up on the server side. And the server actually just agreed with it and said, yep, well, data is free equals true. So this is an example of just a security configuration. So this is an example of not necessarily a specific type of class of bug, but it's just making sure that you test and understand your code. I'm actually not sure. I think there's also another bug that the person got a free Rihanna song, but that's a whole nother conversation. So in this particular attack, the data is free tag. If it is set to true on the client, it should be ignored on the server. The server should be setting that. So in this particular attack, what actually happened was the server wasn't validating and allowed that to progress. No, just this particular attribute was not being checked. So you couldn't change any of the other things without the server picking up on it. It was just this particular attribute. All right. Now this is the more hardcore one. So to start off, how would you escape this piece of code? What do you need to be careful about especially around the user string? Yeah, so you need to make sure that these bad boys are encoded, right? So the problem is that if I need to encode, I need to escape it, because otherwise somebody could potentially put in another single quote, and then they could put in whatever they want and run to town. So is this all we need to do? Should be okay? Someone can give me a hint why you get one of these. Okay, so you need to HTML escape as well. Why do you need to HTML escape? Why? Doesn't make any sense. You got a book and a Chromecast. Good night for you. Awesome. So, well, it kind of depends. So this is where the complexity of these security bugs comes into play. So fun fact on browser decoding, this is the order that it actually happens in. So HTML decoded first, URL decoding, so you know like %20 in the URL gets converted from the gets converted back to the space character. And then at the end you get the JavaScript decoding, which is what we showed earlier, like the /x27 for the single quote gets converted back. So how did this particular person, how do we actually get here? So this is it being escaped, right? So what sort of payload would trigger an alert box? Well, it doesn't check for HTML encoding, right? So what if I have an HTML encoded single quote in there? Then when it all gets displayed at the end, I get this. I basically get my alert box to pop. So how did that work in practice for this specific bug reported in the Gmail web? This is actually the mobile interface. It's one of the many mobile interfaces. I'd send an email containing this completely unsuspicious tag that I'm sure everyone would click on. And then the page would render, as you can see. The page renders with just this portion of it, because what Gmail is doing is it's turning that into a mail-to link. So it looks like an email address, and so it's helpfully turning it into a mail-to link. So then when I click on it, I can open a new compose window and type a mail to that person with the email address already pre-populated. What actually happens in the end is this. You can see we've got here, the single quote breaks that, we get our alert box, and then 2 quotes on the end. What does it look like? That's what it looks like. So there's one of our researchers, successfully anonymized, popping an alert box on mail.google.com. I would say so. I mean, I could hopefully make a living on the amount of money that was going out. But yeah, I think there are people who are professional bug bounty reporters, but they usually report to lots of different programs. So I couldn't comment authoritatively on whether they make a living doing it. So if you're feeling a little like this about all the stuff I've kind of spoken about, like this is just crazy, you know, I didn't even understand that last slide, like what the hell is going on? Don't despair, because these problems have really cool and easy solutions, believe it or not, and solutions that you can take home with you tonight and start using immediately. Because after the break, these two guys are going to show you how easy it can be to protect yourself from security vulnerabilities in your applications without even having to really understand how they're exploited or write any security-specific HTML5 code. Sound too good to be true? Yeah? Well, I'm actually out of time for questions, so why don't we all grab a drink and aim to be back here just on 8 o'clock. Thanks very much.